Alright, let me go over the review test 4, part 1, and hopefully it will help you grasp the material. So if I go to first question, and the question is to use the graph of y equals 5 to the x to sketch the graph of f of x equals 5x plus 2. Use techniques of transformation. So use the graphing tool to graph the function. So as we know, the graph of 5 to the x is an exponential function that looks like this. But now, let's see. So 5 to the x, we're going to use the exponential tool and just graph it. Graph anything that looks like an exponential. But now, because at that plus 2, the graph is going to shift to the left 2 units. So the y-intercept is going to change. If you put x equals 0, then y would be 5 to the power 2, which is 25. So in this case, so the base is here 5. And there is a vertical shift. There is no vertical shift in this case. All we have is a horizontal shift 2 units to the left. Wow, that makes this problem much easier. So again, we have a horizontal shift of, let's see, this is 2, this is minus 1, this is negative 2. Okay, so there is a horizontal shift 2 units to the left. The base is 5. There is no reflection about the x-axis, only if we have a negative sign before the 5. There is no reflection about the y-axis, only if the x negative. And therefore, that's all. That's all what we have to do in this case, and let's save it. So this is the graph. As you see, for x equals 0, y is 25, and we don't see 25 on this graph, so it's somewhere up here. So it does look good. Let's go to the next question. Solve the equation analytically. All right, let's try this one. So now all we have to do is try to solve this problem, and we have 2 to the power 2x minus 1 equals 2 to the power 4, right? 16 is 2 to the power 4 because 2 times 2, 4 times 2, 8 times 2, 16. And now 2's are equal, therefore the exponents must be equal. And let's solve for x. 2x minus 1 equals 4. Add 1 to both sides. That gives me 2x equals 5, and of course x would be 5 over 2. Simplify your answer, the solution set. So let me just put 5 over 2 here. Okay, it didn't say whether I have to do decimals, but 5 over 2 should work fine. Let's try number 3. Another solving equation. So let's try to solve this one. And here we have e to the 10x minus 1 equals, well, this is power to power, and that's 8x. The e's are equal, therefore the exponents should be equal. So 10x minus 1 equals 8x. Subtract 10x from both sides. And this will give me a negative 2x equals negative 1. Divide both sides by negative 2, and x would be 1/2. X would be 1/2. That's all. Use a comma to separate answers as needed. It's only one value answer or one answer, so we don't need to have any decimal part here. Number 4. Find the present value. So here is another problem. We have to find the present value that will grow 29,000 if interest is 5% compounded quarterly for 12 quarters. So we need to find this present value. So let's find the formula is A equals P 1 plus R over N to the NT. So we have P is the unknown. This is 29,000 equals P. The rate is 5%. And then N is quarterly, compounded quarterly, so it would be 4 times a year. N is 4. And then 12 quarters. So 12 quarters, we want the answer. N, of course, is 4. T is in years. So how many years is 12? And 12 divided by 4 is 3 years. So we don't want quarters for the years. We need to change the quarters to years, and we know that 4 quarters is 1 year. 12 divided by 4 is 3 years. So that would be the answer. So let me solve for P. 29,000 equals P. Now this is going to be addition raised to the power 12. So let's see. 1 plus 0.05 divided by 4 is going to be, let's see if I can do this. So that would be 0.0. Let me try and do it here. So let's see. Move the 0 up here. Add a 0. So move the 0 up here. If I do, let's do this way, 5 divided by 400, that would be much easier. So multiply up and down by 100, 5 divided by 400. So that's going to be, since 5 is less than 400, we're going to add a decimal here, add a 0. 50 divided by 400, still not good. So we need to add a 0 here and a 0 here. Now it's going to work. 500 divided by 4 is 1. And 1 times 400 is 400. Now we have 100. And then let's add a 0. 1000 divided by 4 is 2. And this would be 800. Now at 2000 divided by 4 is 5. So that's going to be 0.0125. raised to the power 12. Now all we have to do, put this to the power 12 and then 29,000 divided by all this, and that's how we got the P. So let me do this on my calculator here. So we have 29,000 divided by 1.0125 to the power 12. So let's see again. So 29,000 divided by 1.0125, all of this to the power 12. Enter. So that's the answer, 24983.7, 24983.7. 24983.7. This is to the nearest cent as needed. So we have to put another to the nearest cent. That means 2 digits after decimal. So that would be 75. All right, let's go to number 5. And number 5 is a very simple. We need to change this exponential to log, and we can use that property where we change y equals log of x base a is equivalent to a to the y equals x. Now we are given a to the y equals x, 5 to the power 3 equals 125. That x here becomes here. So now we have a log. The base is 5. X is 125. And y, the exponent, is 3. So here we have to substitute log base 5, 125 equals 3. Number 6. Convert to exponential, and now we're going to do 5 to the power 4 equals 625. So complete the equivalent exponential equation, type your answer in exponential notation. Okay, so we're going to do exponential 5 to the power 4. So 5 to the power 4 is 625. Number 7, the solution set. How do we solve this without using a calculator? Let's see if we can do it without a calculator. So x equals log base 5. Now what is 625? 25 times 25 is 625. So it's going to be 5 to the power 4, and that would be 1. So to move an exponent notation to the numerator, we have to change it to a negative exponent. So that would be log 5 to the minus 4 base 5. We're going to use the power property of log, moving the negative 4 to here. So that would be negative 4 log 5 base 5. But log of any number with the same base goes to 1. And 1 times negative 4 is negative 4. So all we have to do here is negative 4. So again, what we did is change the 625 to an exponent notation. 5 times 5, 25. 25 times 5 is 125, and 125 times 4 is 625. And therefore, we can move this up, make it 5 to the minus 4. Move the negative 4 as a coefficient, one of the power rules for the log. And then negative 4 times log 5 base 5, this goes to 1, so negative 4 is the final answer. Let's try 8. 10 to the power log 6 x equals, so let's try this one. So here we have x equals 10 to the power log of 6. So let's try to change this. Now this looks like an exponential. If we change it to log using the same property, let me write it down here. This is equivalent to y equals log of x base a. Now here we have a to the y. A to the y equals x, so a to the y should be on this side. A to the y equals x. Okay, so x is the same, it's not going to change. So when we write this exponential in a logarithmic form, we're going to have log of x. Okay, now the base is 10, so the base is 10, very good. And this is equal to y, and y is log 6 base 10. Perfect. So this is also base 10. So we have the same base 10, therefore x equals 6. So log of x equals log of 6, therefore x equals 6. So the solution set is, we have to put 6. Solution set is the set of elements containing, so we don't put x equals 6 because this is a set, and we're going to put only the element 6. So 6 is the answer. So 10 to the power log 6 is just 6. You can check this on your calculator. Number 9. Use the graph to graph the function f of log of x2 plus a, then give the domain and range. Okay, this should be very simple. All we have to do is choose the logarithmic function, and the logarithmic function looks like this guy here, and plug it anywhere. And now let's look at the properties. The only thing we have in this case is a base 2, and this is, it will shift vertically up 8 units, so that plus 8 will shift the graph of log of x base 2 up 8 units. So vertical shift up 8 units. 6, 7, 8. Okay. Go back to 8. So make sure this is 8. Okay. And then we have already, it's already reading, I think. So we don't have an option for the base because it's already reading the base 2. So I guess that's all. We don't have a vertical stretch. We don't have a horizontal stretch. We don't have a vertical shift. We have a vertical shift. That's all what we have. We don't have a horizontal shift. So the plus 8 is only a vertical shift in this case. So that's all what we have. Okay, let's save it. And for here, the domain, look at the domain. We cannot touch the x equals 0 vertical line. So they want an interval notation, so it's going to be from 0 to infinity. And parentheses for both because 0 cannot be part of the solution. Log of 0 is undefined. X must always be greater than 0 here. For the range, look, it's going to go from minus infinity to plus infinity. So that's going to be minus infinity all the way to plus infinity. So basically, that's all what we have to do here. So that plus 8 only is going to be the vertical shift. The domain, remember, we go from minus to x, but minimum value for x is 0. It cannot be 0. So if you make this larger, these things should not be touching here. Now the graph, make them look like touching, but it should be asymptotic. It should be asymptotic rather than touching. Okay? The range, well, the range is the y value. This goes to minus infinity and goes to plus infinity. Let's try number 10. Graph the logarithmic function base 2. Okay. So, well, this is the answer. That's a very simple question. Very simple question. Because this is an exponential, this is the log with base between 0 and 1. So if this question was log of x base half, then that would be the answer. And this is a log, the same thing, but it's shifted to the left. Shifted to the left. That's not the case here. So we have basically log of x base 2 should look like this. Now how do we confirm? Let's take x equals, what's this point? 1. Log of 1 is 0. Definitely. So let's take x equals 2. Log of 2 base 2 is 1. That's a 1. Right? What else can we do? Let's try this one. 4. See, it would be 2. X equals 4, that's a 2 squared. Take the 2 outside, you get 2 log 2 base 2. 2 times 1 is 2. So that's how they got the 2. So after you choose the curve, take some points and make sure those points match the log of x base 2. We took like 3 points and they all matched. So that must be the answer. Alright, let's try number 11. Use the properties of log to rewrite the expression. Of course, this is we're going to use the quotient rule and the multiplication. Let's start with the quotient rule. So this would be log of 8y minus log of z. Nothing we can do about this, but this one we can use the product rule. Log 8 plus log y minus log z. Now this is 2 cubed. Do they change it to 2 cubed? They don't. They don't change it. They keep it as log of 8. Okay, and of course this is base 4. This is base 4. That's the final answer. So which one matches this one? Log of 8 base 4 plus log of y base 4 minus log of c. So that's a D. Let's try number 12. Same thing. We need to expand. So let's do the same for this one. So log, we're going to do the quotient rule. So log 7 square root of 6 minus log of 5. Of course, this is base 4 again. And then we can do the product rule. Log 7 plus log square root of 6 base 4 minus log of 5. One more step, this square root can change to the power 1/2 and the 1/2 will come outside. So that would be log 7 base 4 plus 1/2 log 6 base 4 minus log 5. Remember, square root of 6 is 6 to the power 1/2, and then we use the power rule to move the 1/2 outside the log. And that would be the final answer. Which one has a 1/2? Log 7 and minus log 5. So that's the answer. Number 13. Now we're going to put them all. So the addition becomes product, and the minus becomes quotient. So xy over t, xy over t, xy over t, b. So the addition is the multiplication, and the subtraction is a division. 14. Use a calculator to find the natural log base e. So when we go to the calculator, make sure to use the log ln of 0.0697. Enter. And the final answer is negative 2.4 decimals, 6636. So minus 2.6636. Okay, so round it to the nearest 4 decimal. Let's look again. So negative 2.66355, but the 55 here will round to 60. And this would be 6 here, to 2.6636 and the negative sign. Okay, good. Let's try 15. The magnitude of an earthquake measured on the Richter scale is log of I over I0, where I is the amplitude registered on a seismograph 100 kilometers from the epicenter of the earthquake. And I0 is the amplitude of a certain small size. Find the Richter scale rating for an amplitude of, so if this I is equal to 1 million I0, now divide this, you get 1 million I0 over I0. The I0 will cancel. 1 million is 10 to the power 6. Using the power rule, that 6 will move out. So 6 log of 10 base 10 is 6. So that's it. 6 is not too bad, right? Is it too bad for an earthquake? I think it is. So all we have to do is substitute I, 1 million I0, cancel the I0, log of 10, this is 10 to the power 6, move the 6 outside, 6 log of 10 base 10 is 1, 6 times 1 is 6. Number 16, use the change of base theorem to find each logarithm. So we're going to find log of 10 base pi. So we're going to do on the calculator, use the base 10, and now we're going to do, let me put them inside parentheses just in case, log of 10 divided by log pi. That's all. So that's the change of base, log of the 10 over log pi, but now we're using both of them base 10. So I went from base pi to base 10 and I divided. And I'm going to say enter. And the answer would be, you see, it's the same like log 10 base pi, but the answer would be 2 point. They wanted to the nearest 4 decimals, okay, 4 decimals, 0115, right? 0115, 2.0115. And the last question is number 17. Oh, we did this one. It's going to be xy over z. Xy over z. So that's a repetition. And the base is c, so that's it. Submit quiz. See if we made a mistake. No mistakes. Good. I hope this helped.